All right, so we've probably done some basic stuff, at least you should have in theory. So you've got your series circuits down, you've got your parallel circuits down. Let's see what happens when we put them together. All right, so here would be an example of a combination circuit or a complex circuit where you've got both series elements and parallel elements. It's up to you to figure it out. So as with all the other problems, I want you to figure out the equivalent resistance. I want you to figure out the current through each resistor and the voltage drop at each resistor. All right, so that is your mission. On your mark, get set, go. As soon as you're done, or I should say pause it. Okay, so pause your work. I'm sure you're working on it, but pause it. I'll come back, tell you the answers. All right, see you in a sec. Pause it now. All right, this is the first step. Find the equivalent resistance of the entire thing. You should get 15 ohms as your equivalent resistance for the whole thing. Now, how'd I get that? Well, the first thing you have to realize, this is a complex circuit. So you've got a series part here because this is in series with the battery, or power supply I should say. But these two are in parallel with each other because if you look at this branch, you can go up and around or up around, so you've got options. The electron does not need to go with both of these, so therefore these are in parallel. So if I do a quick calculation and replace this with a single resistor, I have 1 over 15 plus 1 over 30 equals 1 over R. And when I do that, basically you get R equals 10. So this is effectively a 10 ohm resistor. And again, whenever you see resistors that are in parallel, they're always, the equivalent resistance is always less than even the smallest resistor in that branch, or in those the set of parallel resistors. So that's your resistance there, you get 10. So once you have that, you have a 5 that's in series with a 10, so 5 plus 10 is 15. That's where we got our 15. Now that we have this, yeah, you know what the next guess is. You got to start finding currents. All right, so we got to start finding some currents. So let's see how we went about solving for those currents. So here's me solving for all the currents. So first I started at the source. And so I said, hey, current flowing through the source, that's 8 because I used Ohm's law. So therefore this is 8 amps. Now if I trace my paths around, it's going to kind of be splitting up in these branches here. But it goes straight through this one, so I also know that this is 8 amps. So now if I know this is 8 amps, it's going to split up in 8 amps here. What I can also solve for is I can figure out, okay, if that is 8 amps, then I can start looking at some information over here. And to do that, I actually have to include an extra step, which I forgot to transpose when I was adding my notes, is that I want to figure out what's the voltage drop here. So if I want to figure out the voltage drop at this guy, well, V equals IR, so 8 times 5 is 40, so this is 40 volts. And so if I started with 120, I lost 40, these have to be 80 volts each. So those are each going to be 80 volts. And then I can use V equals IR again to find the currents. Because I know the voltages, I know the resistances, I can find the currents. And so that's what I did. I was like, I missed a step. Something's wrong. All right, so you have to do that step first. And then you say, well, 120 minus 40 is 80, so these guys are 80. Now I can use V equals IR, just like I did over here, to find the currents. So the current going through the 15 is 5.3, and the current repeating. And the current going through this one is 2.6 repeating amps. So now I can say, well, am I doing this right? And to do that, what do you have to do? What do you have to do? That's right, you got to check yourself. All right, so let's check ourselves. So here I check myself. I knew that going into this node, I had 8 amps. So then through both of these branches combined, I need to have a total of 8 amps. So when you do 5.3 repeating plus 2.6 repeating, you get 8 amps. I am good to go. I have done all of this correctly. No, you're supposed to erase that, yeah. All right, so go through it, piece by piece, step by step. Whenever you do these complex circuits, you have to use a combination of your rules, like V equals IR for this piece, but then use your rules about series versus parallel circuits for the next piece, and stuff like that. And then when you're all done, make sure that you double check your answer by using whatever you solved for. So again, the last thing I solved for was current, so I made sure that I used my rule for current to double check that I was doing it right. All right. It's been exciting. Maybe I'll do some more later, but I'm going to watch some TV now. You have fun.